quiet. We're recording. Don't say anything you shouldn't. Okay? So, this is the fireworks problem. Stop talking. Put away your cell phone.
Oh.
Yes? No, not right now. I can't play that game in Spanish. Is that in Spanish?
No.
Oh, I can do it. So these problems here, shush, 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 shush. Say, you're being recorded now. I'll send this video to your dad. All right. So, fireworks display, suppose that two people are standing 2 miles apart. God bless you. So, these are kind of contrived problems in that they're kind of weird because it wouldn't occur that fireworks is directly north of someone else. But what happens is someone sees there's a firework, there's two people standing 2 miles apart. So let's call this person, let's call directly north of person A. So here's person A and here's person B. I think we did one, and their distance is 2 miles. And since everything is in feet, we're going to call this not 2 miles, but 10,000. How much would that be? 550? How much? 10,560 feet, right? Apart there. And then what happens is this guy over here, the first person getting out, here's the burst. 1 second later, the person at point B sees. So here's where the fireworks is. Are. And this person sees the fireworks. So let's draw a nice dotted line up to this fireworks in a different color. Okay? And so this person sees the fireworks directly north of him. And then 2 seconds later, this person sees the fireworks. All right? 1 second later. And what they tell you in the book, what they want you to do is model this as a hyperbola, okay? And so what you do is make this is a point on a hyperbola that looks kind of like this, okay? And there would be the other half of the hyperbola would be over here. And what's unique about a hyperbola is this distance here minus that distance here is always equal to a constant. So if I go from here to here minus here to here, that's equal to the same number. Or if I go this point on this hyperbola minus from here to here, that thing is a constant as well. So what we know is that this is 10,560, and we also know that it takes 1 second from the time this person hears the burst to the time this person hears the burst. And since sound travels, they tell you in the book, at 1,100 feet per second, per second, that must mean that for 1 second, the difference since the difference in the time they hear the bang is 1 second, that must mean that their distance apart is 1,100 feet per second times 1 second, which is 1,100 feet, right? So what that means is that this minus this is 1,100. But any point on the hyperbola, if I subtract the distance from here to here minus the distance from here to here, that's also equal to 1,100, right? But also if I subtract this minus this, what do I get? I get the distance I get 1,100, but that is also this minus this will also give you this piece right here. You understand that? Because these two things, this piece here is congruent to this, right? So say, for instance, that this is 10 and this is 10, right? And this is 30, just for a little side show here, right? So if this is, the distance from here to here is 40 minus 10, what do I get? 30, the distance between. You see that? Okay, so since this is modeled by a hyperbola, okay, wherever you are, this distance from this point to this. This is the definition of a hyperbola. It's the curve whose any point on that curve, the difference from here to here minus here to here is always a constant. So since this minus this is 1100, this minus this also has to be 1100. So this distance right here is also 1100 feet. See that? 1100 feet. It makes sense. Okay? And then if what?
This whole thing is 1,000.
Yeah, so really they're way closer. It's not to scale.
Okay.
Definitely not to scale. Okay? So if I were to draw an XY axis in here, whoops, I need my straight line tool. So if I were going to draw an XY axis right down the middle of this thing, like that, then the distance from here to here is, this is A, right? And this is C. So I know that this is a sideways hyperbola of the form x squared over a squared, because it's x comes first if it's horizontal like that, minus y squared over b squared equals 1. See that? That's an A right there. And I know what A is. A is the distance from the center, even though this is point A, it's from the center to the vertex of one of the hyperbolas. So A is going to be what? No, half of 1100 from here to here, which is 550 squared. Minus y squared over b squared. Now to get b, I don't know what b is, but I do know what c is. C is the distance from here to here, right? So I know, using the Pythagorean theorem with hyperbola, you just use plain old straight old c squared equals a squared plus b squared for hyperbolas. Okay? And I know that c is half of 2 miles, which is 1 mile. So I have 5280 squared equals a squared, which is 550 squared plus b squared. And then if I solve that for b squared, I'm not going to solve for b, I'm going to solve for b squared. B squared equals, let me look in my book, because I did this beforehand. B squared ends up being 27,575, 900. What? I said B squared ends up being 27,000. 575, 900. 27 million, sorry. 27 million, 575,900. Okay? And then, well, you don't have to unsquare it because the formula just wants b squared in it. So we have 27,575, 900, this big, huge number in here. Okay? And then what they want to know is how far if the display is known to occur due north of person A, where did the fireworks display occur? So in other words, how far from person A did this occur? We already know how far in the x direction this occurred, right? This occurred, what's this point as far as x goes? 5280. So if I take 5280 and plug it in there, okay? 5280, no, this is 0, 0, right? And this is 2 miles. So this is 5280. I plug that in. I square 5280. I divide by 550. I subtract that number from 1. I multiply through by this. And then I take the square root. I will get that y is, once I plug that in, I get out, I'm not going to do the math. I get out that y is about equal to y is about equal to 50,180 feet. 50,000? 50,000 about equal to 50,138 feet. Got it? And then they probably want to know that in miles. So if I divide that by 5280, divide by 5280, I get that y is about 9.5 miles. And that's how you do that problem. It's kind of a weird problem in that this has to be directly above this, but it doesn't have to be. You could say, okay, if we know that the burst occurs at, I don't know, 6,000 feet from the center, whatever that center is, then how far away up that way is it from so? Okay? Kyle asks, are A and B the foci? Yes, and the answer is those are the foci. Should have said that at the beginning. Thanks. Bye.